This is Algebra 2. The question was on closure problem B-110, just part B. So I'm going to just do this part B problem where we're going to write the exponential equation that would have these 2 points on the graph. So recall that an exponential equation is in the form of y equals a times b to the x. Well, we have 2 pieces of information. We have an x and a y in this piece of information. We have another x and a y. That allows me to write 2 equations. The first one being 3.5 equals a times b to the 0, which is using this first point, the x and the y, and the second equation using the other x and a y. But in the first equation, since b to the 0 is just 1, we recognize that this just gives me that 3.5 is a. So I'm going to take that and plug it into the second equation, which will give me this resulting equation, and I'm here to solve for b, so I divide both sides by 3.5, and I end up that 31.5 divided by 3.5 is 9. So b squared equals 9. Taking the square root, I find that the base is 3. And we had learned that there were parameters, this a and b, and restriction on b was that it had to be positive. So even though the square root of 9, when I say what squared equals 9, it could be positive or negative 3. Because this is going to go into an exponential equation, I know it's positive 3 only. And I take those 2 pieces of information, what the a is and what the b is, and I can write the exponential equation. The next problem was closure B-111, and we've got some information about a first term and a second term, excuse me, a first term and a seventh term, and to come up with 2 different forms, one arithmetic and one geometric. So I'm going to do arithmetic first, and that would be saying I have 8, and you'd add 6 common differences because from the first to the 7th term there are 6 additions that would happen, and that would get us to the 512. So we can solve for d, and we get that d is 84. That allows me to write the arithmetic sequence, which would be t of n is equal to the first term plus the common difference times n minus 1. But you should distribute the 84 and collect like terms, and when you do that, the equation simplifies to 84n minus 76. We also need to look at it as geometric. So with the same information that the first term is 8 and the 7th term is 512, I can look at this and say, well, starting with 8, you would have 6 multiplications, or multiplier to the power of 6, and it would equal 512. We need to solve for r, so we're going to divide by 8, and we get that r to the 6 equals 64. But this is where you're just seeing numbers and understanding that 64 happens to be 2 to the 6th. So I'm asking, what to the 6th? And I said, well, it's 2 to the 6th, so r equals 2. We're now going to use that r to write the geometric sequence equation, where t of n is equal to a times 2 to the n minus 1. And that would be a perfectly fine answer. But you might notice that this 8 happens to be 2 to the 3rd. And so we could take this exponential equation here and write 8 times 2 to the n minus 1 is 2 to the 3rd times 2 to the n minus 1. Now I am multiplying like bases. And if I'm multiplying like bases, we would add those exponents, and so you would get 2 to the n plus 2. And this is really nice because it is a completely simplified form of the geometric sequence. But either one of these would be fine. In closure 118, we're asked to write a recursive equation. So we need to first analyze this chart and notice that at this first input, the output is 6. And at the second input, the output is 18, and at the third, if we follow the line 3 all the way up here, we get to 254. So those were our 3 terms in this sequence. And we need to find the pattern, and I notice that you just keep multiplying by 3. And not writing the explicit equation and writing down what the multiplier is and all that, just kind of say what's going on here, and we're saying that we just multiply the previous term by 3. That's what you're noticing. It's usually in that simple statement that we're thinking recursively. And so we would multiply the previous term by 3 to get the next term in the sequence. Well, the previous term, the notation for that is t of n minus 1. That would be the one before. And the next term would be the t of n. So our formula for in recursive is saying to find the next term, you take the previous term times 3. You have to include one of the terms in the sequence for it to be a truly recursive sequence. Otherwise, we wouldn't know where to begin the sequence with.